When you're going through and evaluating these failures or looking for these failures, you may want to find out exactly how they're performing. If we look at plate buckling and we see we have a couple of patches here that are failing, the other thing we can do is during dynamic query, when we have this up, we can view what the values are. But if you right click, you can also say launch the evaluation dialog, and that's for this patch. When we launch the evaluation dialog, this is the one we were looking at just earlier, where you can create one. It'll show us all the data that was used for that evaluation. We can see that this particular patch has a length of 2 meters, width of 1 meter, plate thickness. The material is the ST24. And if you right click on the material, you can get a quick check of what some of the properties are. There are no stiffeners. We can see what the various stresses are that were being used during the computation. And I would need to look up what the 1.1 and 1.2 are on the edge supports. We can see it was being evaluated against TSVR rules. The input data, being automatic, is taken from the model. If there was an issue with this patch, let's say we knew that because of how it was modeled, or maybe it wasn't perfectly uniform the way it is here, if there was a taper to one end, if we didn't like the value for the width that it created, or if we were looking at something on the shell and we knew our stiffener spacing on the shell was supposed to be a standard 0.95 meters or something, and it's showing up as 1 here, we can switch over to user defined, and this will allow us to change any of these values. We could come in here and change the width and see whether or not it would pass with a slightly smaller value. If I hit compute here, it'll show us what the evaluation is using all of these values. And since I didn't change anything, these are the values that it created from the defaults. It asks, when you hit compute, this dialog asks, would you like to overwrite the adequacy parameters? So you can basically replace the results in the model. So if you know that the modeling had, some minor deviation in terms of what it interpreted as the width, or you wanted to use something different, you can alter it here and you can overwrite the data in the results file with the updated patch information or the user-defined patch information. For now, we'll just take cancel there. But if I made that 9, I could recompute. I believe that was a 0.2 something previously. So 133.172. If we go back to the default, yeah, this was 133.172. Now it's 161.208. So you can see the effect there, and we could overwrite that in the results. The optimize is if you have the optimization module, it will allow you to run through the various materials and or available stiffeners to sort of optimize this particular patch. But it only does this one particular patch. And I believe it keeps the stresses as a constant rather than adjusting them for the different dimensions of the scantlings. So it's sort of a very simple optimize, but well, if you don't have the optimization module, this won't work. The other option here, we're not really creating anything. This was pulled out of the model, but it's a standard dialog. So you could create new patches using this dialog. But the patches that you create, I don't think are tied to the model for retrieving data. So we could modify this patch or delete it. But the other option here is mesh. Now, this mesh option, if we click this button, it wants to create a fine mesh module here for this patch. But basically, it's just using data from this patch to define sort of a generic one. You can specify how many elements you want, longitudinally and transversely and so forth. But if we create this patch, while it is a fine mesh patch, you might be expecting it to replace this patch or create a fine mesh version of it in the model. That's not what's going to happen. This area here, if we create a patch from this dialog, so I just created that, and we can see patches created, the new fine mesh patch. Here is our hull, and if we want to see both of them at the same time, we'll say view all modules. But you can see the patch it created was just a sample patch based on those parameters, and it creates it up at the origin. Now we can load this and evaluate it, but it is not sort of an embedded fine mesh version of the existing patch. If that was what we wanted, and we'll do a little bit more of this when we do the fine mesh portion. But if we wanted to replace that patch with a fine mesh version for further evaluation, you do that via a general group. So we would create a new general group and would say we want to add a patch, and we'll add that one patch. I do have patch set on my query. Why is it not? That may have broken my evaluation patches when I ran that create mesh, because you can see when I'm doing it, all of my patches are now individual elements. Redefining that patch may have broken the existing patch definitions. So we'll simply come in, generate new patches, and now when I query, I got my patches back. So if we wanted to replace that with a fine mesh patch, we would come in here, generate a new general group from that patch. We could put in more than one patch if we wanted to do a whole section of patches there in a fine mesh. General group 5 is what was just created. We simply right click on it and say refine, and we'll just accept the defaults here, and it'll be a top-down model, so it's not going to replace the existing patch that's in there. It'll just make sort of a duplicate copy on top of it, and you can see it's in approximately the correct spot. And if we do view all modules, created a similar patch there. So the next time we go through and evaluate, we can evaluate that submodule and get more refined information on it. But if we wanted to do a more careful evaluation of any of our failures, you could do that. Normally, you'd be fixing these items at the course mesh scale. I just wanted to show you while we were here, the option mesh in that dialog is not the same as creating the fine mesh sub model.